what we're going to do today for class is have you guys show your solutions to the problems on the homework that, well, you don't have to turn in until a week from today, that I assigned last class period for us to go over in class today. So I know Trace is already jumping at this, but I will have each one of you choose one of these first five, and then each one choose one of the second five. So who wants the first one? Trace was the first one up. T for Trace. Who? Everybody's shooting their hands up. Okay. I can't show favoritism. It's hard.
Wait, so we choose one of these problems?
Yeah.
I can do B.
Which one do you want to do?
B. Is it B?
Well, everybody raised their hand for B as soon as I was getting there. So I will just choose, well, I'll choose a random number between 1 and 3. Okay, I've chosen a random number between 1 and 3, and then I'll have each one of you choose a number. So say a number.
Wait.
Okay, it was 3, so.
Like if they all said the same number.
Yeah, for sure.
Well, at least it's not the first one to answer necessarily. So now it's down to 2 people. Do you both want to do C, or somebody wants C and somebody want D or E?
I'll do C.
What are you feeling, Michael?
I'll try E.
You'll try which one?
E.
E, all right. And that means that Richard gets D. And then we're going to go to integrate the same, integrate the same things. And what did I do? There we go. To integrate the same things. And so just because I want to try to be fair and not have one person automatically get it. So starting with A. Okay, so I have numbers between 1 and 4 down here. Everyone who's interested in, who prefers A, that's your first choice. Go ahead and choose a number.
2.
Once again, she just picks whatever number I have here.
Probably nobody wants A anyways.
I don't know. I haven't gotten this far since.
I just don't want to hit the first one twice, to be honest.
Okay. For B, everyone who's interested in doing B, choose a number between 1 and 3.
3. I'm not interested in B, so.
What about you, Michael?
Oh,
Are you interested in B?
I'll try B.
Okay, then choose a number between 1 and 3.
B.
Well, Nathan took 3, so between 1 and 2. Because it's not 3.
2.
Nope, it was 1.
Please. You're pretty close. Anyway.
Yeah, okay, so Michael. Okay, for C. Between 1 and 2 for either of you if you want C.
I'll go with 1.
It was 1. Nathan, you want D or E? Okay, E you have to use the computer for. So I'm going to give Nathan. Why did I put 1 there? That should have been Trace.
Because I attempted to help you on that one, but I couldn't.
All right, so let's go ahead and just get started now. So first up will be Trace. So Trace, you're going to come here and just go over, well, you can start, yeah, there's not much space. Just go over to the right here and swipe to the right and just do it here on nice clean paper. Interesting.
Just so I remember what the problem even says.
So it says,
Yeah, I got this.
oh, you got that. Okay.
Isn't,
You'll need this.
yeah. Do you have to push a button or just go? Okay.
No.
Okay, so go over here. Problems. No, how am I going to do this? The benefits of being left-handed, there's not many. Okay, so f of t, it's 5t squared minus 20t plus 17. So honestly, there's only two rules that you.
Figure equal sign and plus sign. You
Uh,
said
oh,
that
I
didn't write them.
Yes, I said them, but I did not like them at all.
And the equal sign was again.
Okay, so there's only two rules we can use here. One of which is the power, and the other of which is the constant. And to do the derivative of a power rule, what you do is you bring down the exponent and take away that exponent. So it's n minus 1 where the exponent is, and you bring it down. So it will be, I don't know what I pressed there. It'll be, 10t minus 20. And this is indefinite, so plus c.
Well, no, this is derivative, see?
Oh. Yeah.
So no plus.
How do I take that away?
Hmm?
Do I just
Just
use...
turn around and use the other side like you erased.
Oh, okay. Okay, so it'll just be 10t minus 20.
Now, the way I would like it written for this assignment only, never again,
Never again.
is to put parenthesis 2
Oh, okay.
times 5t raised to the 2 minus 1.
Okay. So,
Right, because it just shows, yes, I
So-
knew exactly how I got there, not just that I was able to get the right answer.
and then, I guess whatever. So minus 20 t, well, t to the 1 minus 1.
All right. Yes, that makes it
Yeah.
real clear. You know exactly that's how I got there.
Okay.
All right. Good job. Next up, I don't remember, but it says up there. That's Kaylin. That's her.
Just use this?
Yeah.
Okay, so I have number.
Just to make it clear, why don't you click like a different color pen up there at the top?
Like that?
Yeah, sure.
Okay, cool. So I have F t equals 6 over t squared. We're going to use the spell check, I don't know. Which is like high d low minus low d high over low squared.
Now that does work, but it's a lot more work than necessary.
Oh, well, that
Right?
was
You're
the
not
one I
going to be
did.
wrong if you do that.
Okay.
But the easier way, and I'll tell you how to do it the easier way and have you do it that way simply
Okay.
because you're going to be able to do it. The easier way is to simply rewrite it as 6t raised to the minus 2. Right, that's the same equation.
Yeah. Where's the n? So we can use, what is this, the power rule then?
Yes.
Okay, so it's 2. Oh wait, I don't want to write it like that. Just do this. Let's see. That's it, right?
That was perfect.
Cool.
See, it's a lot easier than using
Yeah.
the quotient rule. Would have worked, but. All right, next up, was that Michael or Nick? Okay, Nick. Okay. So once again, just change colors. That way it'll be clear. We're doing a different problem with a different color.
Okay, gonna be blue. All right, so we have
And just use your finger to scroll up.
cool. All right, we have f of t is equal to 24 e to the 3t. That's our original function. And so from there, the step I took was right, So I used, so this is f prime of t. And then I used a combination of the chain rule and the E rule. I'm not sure what that's called. So that so the chain rule means that we take the derivative of the inside of the exponent of e. So that means that we have 24 times 3 times, and then e to the 3t, that stays the same. So according to the E rule, so we have that, which means we end up with 72 e to the 3t.
Okay. And last for the derivatives, Michael.
Where you
I think
scroll
you can
down.
go ahead and work out over there now because we'll have enough space here probably for you to finish.
All right, so let me see here. T cosine. All right, so we have. How do we erase? Is it right here?
You turn around.
Oh, it's, okay. Okay. Unlike a regular one. All right. See, we have f of t equals t cosine t minus sine t over t squared. So I believe the rules that we need to use, I believe one of them is quotient rule. Obviously the rule of cosine and sine, if I'm not mistaken, right?
Yes.
Okay. So what we would need to do is, I believe the rule for quotient rule is for u over v equals u and then v prime minus vu prime over v squared. Let's see. So what we do is we plug them in. Let me do it under here. Okay, so u, that will be t cosine, so we just write it in. Minus sine t multiplied by t squared, which will move the exponent down, so it'll be 2t minus, let me extend this, v, which is just t squared, times u squared, so that means, okay, so minus sine here, I haven't forgot about the t yet, I'm just writing this in, sine t minus, will be, cosine t, right? Is it correct? Or is something
We're doing the derivative now,
Mhm.
and so I don't get confused.
okay?
I'm going to take the first term, t
Mhm.
cosine t,
and you have to do product rule there.
Okay, product rule.
And so the product rule, you're going to have derivative of t is 1 times cosine t. So you're going to have
Okay.
cosine t first,
All
and
right.
then you have t times the derivative of cosine t, which is the minus sine t. So you have cosine t minus
Cosine
sine
t. Okay. Minus sine t.
Minus, and
What?
no,
Wait.
you have cosine t minus t sine t,
Okay.
because the product rule of t cosine t. Right, you had forgotten the t, so I understand.
Yeah, I haven't put it in yet, so.
Because if there was no t in front, that would be right.
Yeah. Okay, so I put the t back in the front. Right.
Well, when you do the derivative, you're going to have a t on this one, on the one that you have written.
Okay.
So just put a t right in front of that minus sign, or excuse me, after the minus sign.
Oops. What happened?
Click, see where it has the n icon that's underlined at the bottom.
Okay. So you're saying again?
Okay, so right now you're starting with minus sine t.
Yes.
It should be minus t sine t.
Minus
you
t sine
throw a t right in front of the s.
Yeah. Yeah. Okay.
And then we have to have the derivative of the first times the second, so we have a plus cosine t.
Okay.
Well, that minus cosine t was correct. That was the derivative of minus sine t.
Okay.
And so those are going to
Got a little bit confused there. Okay.
So you still have a plus cosine t missing.
Okay. Let me see if I can plus cosine t. Okay.
Now, you're technically missing the plus sign because you used the t from cosine t as the plus sign between those two.
Wait. I'm sorry. I got confused.
I'll come up here.
Okay.
You have the derivative of the first term is minus t sine t
Mhm.
minus cosine t. And then you have, actually it's minus t sine t plus cosine t. But this needs the plus sign right there.
It's right there. Oh,
That's the
yeah.
t. That's
Oh,
what
see, it's confusing
yes.
t in
Yeah.
the plus sign. Okay. Let me fix that. Cosine t plus. What did I have written earlier?
Cosine t.
Okay. All right. And that will be over V2, which is so
Well, t squared.
yeah, that's what I meant.
Your brain's going faster than your hand.
Yeah. Okay. Now, after we got this, we can simplify it. We can multiply it out, I believe, if we can.
To make
Oh,
it
wait.
easier, go ahead and just squeeze like this to shrink it a little bit. And so you can see
Okay.
the whole equation at once.
All right. Okay. How do we simplify this? Okay, so we multiply in there, right? Within.
Well, first thing to do is you have minus cosine t plus cosine t. So those add up to zero. So just scratch them out.
Which one again?
The last two. You have minus cosine t plus cosine t. Right, those add up to zero.
Oh yeah, I see that now. So I can cross this out over here, which leaves t squared multiplied by t sine t. And then on this side, here we have t cosine t minus sine t multiplied by 2t.
So now we want, well, one thing to do is to cancel a t from every term. Right on the bottom, you have t to the fourth.
Yes.
Make that t to the third. And then cancel where you have 2t, cancel the t. And where you have t squared, cancel the square.
Okay, so this will be crossed out.
Yes.
And then one of this will be crossed out. So it will be t. Let me write
Yeah,
this.
you're going to have to cross that whole thing and put t cubed in the bottom because
Yeah.
t.
So t cubed here. And then we have, what is it again? T cosine, right?
Well, you might as well bring the 2 over, so 2t cosine t.
2t cosine t, yeah. Okay.
Minus 2 sine t.
Okay, here we
Got
have
the
that.
sine part there.
Where?
It's minus 2 sine t.
Minus 2 sine t. Yeah.
And then our last term, minus and minus is
Minus.
plus.
So we can just kind of make that a plus right there.
That's going to be t sine t.
And let's see if we can simplify it anymore. I don't think we can.
You can
Thank you.
rearrange, but it's really not simplifying anymore.
Yeah, this is the simplest, so that will be the answer, I'm guessing.
I'm trying to figure out what I did because I have
Yeah.
something slightly different, but I think you did it right.
The other t, what would be multiplied by t sine t? Because you only got
Which one?
one of them.
Oh, right. That's, yeah. It should be, the last one should be t squared sine t. That's what you're saying?
T squared,
Yeah. Because
Which one?
Because it was t sine t in parentheses. Yes, that last one's t squared.
okay.
Yeah, I was trying to figure out why was mine different. That was a lot.
You mean at the end, right?
Yes, the last,
The last term?
not the whole thing, but the t inside is squared. The t before the sign in there is squared.
This one?
Yeah.
Okay.
Or no.
Wait.
Sorry. It's hard to tell where the pens until you actually put it down.
Yeah.
This one here.
Okay, this one's square.
The reason being,
As Katie pointed out,
Mhm.
that we had a t here and a t squared. We canceled
that
one of these t's, but we still have one here and one here.
Okay.
Okay, now it's my turn. And mine is
Well, I will just come up here and put it above everyone else. Mine is on this side of the page. Very good. So mine was this beast. Now, the first thing to do with this beast is to realize, what does it mean if I have e to the 5t quantity to the fourth power? What we do there is we just multiply the exponents. So this is exactly the same thing as 7t e to the 20t. And once I write it that way, it becomes easier. Now I'm going to have to use both the product rule and the chain rule. So if I take the derivative, and here, look, I'll put f dot because technically that's how we do it in physics if we're doing a derivative with respect to time. I'm going to have the first times the derivative of second, so the first 7t, derivative of the second, using the chain rule, derivative of e to the u is e to the u. So I have e to the 20t, but then du dt, since the u was 20t, the derivative of du dt is 20. All right, but t to the 1 minus 1, which we know is just 1. And then continuing the product rule, plus derivative of 7t is 7 times e to the 20t. 7 times 20 is 140 t plus 7. There's my answer. All right. Now, of course, I went faster because you know what I've done? This problem recently. And I assigned it. Any questions about what I did? I'm going to check my answer key and see if I got the same answer. Yay! All right, now to the integrals. So the first integral is Kaylin. And I don't know, you can go to the right or below. I don't care. We'll leave you that. And probably zoom in a little bit again. I should have zoomed in before I started.
You can just touch the screen.
Was that a pizza my heart shit?
Yes. Capitol?
Yeah.
California.
I grew up there, yeah.
Oh, nice. I went there my senior trip. A lot of fun.
Anyway.
Sorry, continuing on.
Pizza my heart too, you see that.
Yeah, my brother almost died in Capitola because we went to, do you know Margaritaville?
Uh-huh.
Yeah, they serve peanuts there. Didn't tell us that. And then he ate it, and we went to the hospital on our last night.
Oh, how fun.
Super fun. Can I just?
To Dominican Hospital?
Yeah.
My sister was one.
Oh, nice. So I was just going to take the integral of each individual one,
Okay.
and then it would just be...
Now, one thing that is important, you have to have a dt with each one of your integrals.
Oh, like in front of the...
It has to
Here.
be after the integral sign and with the other stuff. It could be on either side of them, but it has to be in there.
My bad.
Now, to make sure everyone, some calculus teachers are more particular than others. And I know I'm technically not a calculus teacher, but I'm really particular on this because number one, that dt carries units, right? It carries units of, in this case, time. Number two, it's telling you what you're integrating with respect to. If you don't have it, how do you know what you're integrating with respect to? Maybe I'm integrating with respect to v and t is, a constant.
Mm-hmm. Okay. And then it's 5. It's... Well, I did something.
Just click down there at the bottom where it says the n.
The N? Okay. Just do that?
Okay, there is,
No, I did something wrong.
well, there's two problems.
Okay.
Problem number one is you didn't do the third integral.
This one here?
The integral of 17 dt.
Okay. I maybe remember the rule wrong, but I thought it was just a constant. If it's just 17, there's no t in regards to it.
If it's a derivative, the derivative of
Okay.
the constant is 0. But an integral, the integral of dt is t, because you're taking
It's t.
t to the 0th power, raising it by 1.
1, then it's t1. Okay.
And don't put the c back, because that was the other mistake.
Don't put the c back. Okay.
And don't forget the 17. There was a 17 multiplied by the dt, so it's 17 t. Okay, now the second mistake I said, don't put the c back because this is not an indefinite integral. It's a definite integral. It has limits.
Oh, okay.
And so our limits were from 0 to t final.
Okay.
So technically you should go back on each integral sign, put 0 at the bottom, t final at the top.
Okay. Did not see that. My bad. Okay. Do you want them on each one? Or
Yes.
okay.
Because I do want it to be technically correct.
Yes. Okay, so 0 to t.
By the way,
Oops.
the upper limit was t final. Lower limit was 0.
Yep.
You don't need to erase the others. Just at the bottom right 0, at the top right t final. Okay, so then the next one, we should have a bracket around the whole thing. And then the right-hand side, at the bottom, you put your lower limit. At the top, you put your upper limit. And then for our answer, we put in the limits. Now, if you put in the limits, in your case, when you put in 0 for t,
Mm-hmm.
the whole thing's 0, right?
Yes.
And so
it's really
it's
just
always
TF.
the upper limit minus the lower limit. So you just put t finals on all those, and you don't have to put minus 0. I won't make you do that.
Okay. Okay. I see.
Got it?
Yep.
The difference here is when you have limits, most real problems have limits. You're starting somewhere and ending somewhere. When you don't have limits, they put the plus c for the offset you're going to get when you put in the limits.
Okay. Got it. Cool.
All right.
Had it.
Nathan,
Wait, I'm not next.
I thought you were.
No, no.
Who is it?
I think it's.
Michael?
Is that the Nathan? Which one?
Were you the one that shows number
Yeah.
two? Oh, yeah, there
I'm
it
letter
is.
C. So.
I probably should have, yeah. Yeah.
Should have what? Should have what?
No. They're joking. They're saying it would have been easier, should have done it.
Okay. Okay, so we need to find the integral of.
So zoom it out.
Yeah.
We don't want, or zoom it. I mean, yeah, we don't want. You'd end up writing in huge letters.
Yeah. Okay, so 6 over t2. If I can just recall the rule for the integral for fraction, then that'll be much easier.
Just like what we did with when she did the. Was it her?
Did anyone else what rule was? Because I don't honestly remember.
Yeah.
When we did the derivative, it's easier to simply rewrite it as 6t to the minus 2.
6t to the minus. Oh. That makes sense. That makes sense now. Okay. So, do that. We just move up to t2. Okay, and then, let's see. Let's integrate it here.
It's no longer f of t, so it's integral of f of t, but
Integral of, all right. Is it t to 0? T to 0.
that's t final actually.
T final.
The reason it's t final is because you can't have the limit the same thing as your variable of integration.
Okay. So we have. Oops. Yeah.
Check mark.
Yeah. T to minus 2. What do? We
Well, first
raise
we're
it
just
up.
writing, so 6t to the minus 2 dt.
And then we figure out the rule for this one, which is you raise the power rule, you raise to the power over its same. So that means, let me scroll down. It will be equal to 6 t to, what is it, minus? Okay, so if you're adding the power, that means it will be subtracting from this one,
Well,
right?
still start with writing the minus 2,
Okay,
and then you're adding 1, so plus 1.
yeah, plus 1 over 2, right? Yeah. Is that correct? If I
Minus 2,
okay, so we're at okay,
because you're dividing by the new power.
yeah. The new power will be minus 2, right?
Well, it's minus 2 plus 1, which
Which is
minus
1, minus 1. So basically it's minus 1. All right. And then the answer we'll get, let's add it here.
So we need to have our limits indicated here. So like I
Okay.
had with her, put the square brackets around it.
All right.
The
Oh,
integral sign, square brackets. And at the bottom you have the lower limit, at the top you have the upper limit. And erase that.
Which one?
6 in there.
Oh.
Okay,
okay,
so now we put in the limits. And this one's not as simple as Caitlin's was.
okay. Let's see.
What's the easier way of writing t to the minus 1?
T to minus 1.
What's an easier way of writing t to the minus 1?
We can put 1 over t.
Yeah, so just make it, and since you have a minus, just make it minus 6 over t. Okay,
With the brackets around it, right?
okay.
Isn't there another step to this, or?
Finally, we plug in our limits.
You plug in, wait.
So you plug in, first you plug in the upper limit. So this is equal to, and then the first term is going to be,
I'm confused for a sec. So you plug it into the upper limit and lower.
Yeah, we plug the upper limit into this equation,
Okay.
and then we subtract, plugging in the lower limit.
All right.
It's not T final, it's your answer is equal to, but not T final.
Let's see what I have. So I'll just say F of T then. It's equal to
So far, so good.
this one. All right.
Final.
Final on the bottom. I mean at the
Yeah,
top.
because you're plugging in the upper limit, and the upper limit was T final.
Okay.
So instead of T, you're putting T final for the first one.
Okay.
And then you're going to subtract, but staying on that same line, you're subtracting, and now you have parenthesis minus 6 over your lower limit.
Over 0.
Yeah.
And then that just ends up to be minus 6 plus, it will cancel out. Wouldn't it? What was it?
Well, something minus undefined.
Something.
You have 6 over 0 is undefined.
Yeah.
And if I have 7 minus undefined, what's my answer?
Undefined.
Undefined. So you're just undefined.
And that's it.
That's it.
All right.
Now, see, this is why putting in the limits, you have to be careful with it. You
Okay.
can get an equation that looks fine, but when you put in the limits, you're like, uh-oh, there's no value.
Yeah.
All right. Next up is trace.
Okay, so it is 24 integral of 24 e to the 3t. Okay, I'm gonna actually let me get that so it's actually legible. Okay, I'm gonna actually rewrite this. Since 24 is a constant, it can actually just be pulled out front.
Make sure you throw your dt in there.
Oh, yes, dt. But since 24 is a constant, it can just be pulled out front. So we're going to do 24 integral from 0 to t sub f of e to the 3t. Wow, I suck at this.
Close.
From e to the 3t,
dt.
dt, yes. And when you integrate this, e, okay, so this is e. So e should still say the same, shouldn't it?
Yes.
Okay, so that kind of makes this really easy, which means you get 24. Oh, I should leave a space. E to the 3t, but you need to multiply by the reciprocal because it's an exponent.
Right. This is, it's
So-
exactly the reverse of the chain rule. And so what you're really doing here is a U-substitution. You set U is equal to 3t, and so du is equal to 3 dt, which means dt is du over 3. That's where your over 3 came from.
Okay. And then you can simplify, which just gives you 8e to the 3t, and then brackets from 0 to t of f. And let's go down more. So that gives you 8. Gives you 8e, well, e to the 3t sub f minus 8e the 3, I hate this, 3t sub 0.
Not t sub 0. 0.
Oh yeah, 0, sorry. And 3 times 0 is 0, and e
Okay,
to the
yeah.
0.
Make sure you put something that indicates multiplication and not the number 30.
Oh, yeah. There should be parentheses there. And 3 times 0 is 0, and e to the 0 is 1. Okay. So then you have 1 times 8, basically. So then you get 8. Oh, actually, no. I'll just show it that way. 8e to the 3t sub f minus 8.
All right. Good job. Nathan.
Okay, so I'm not 100% sure about this. Just to forewarn you.
Oh, good.
Okay. So our starting function is f of t equals 7t times e to the 5t. And so right away we can simplify this to say e to the 20t. Let's get that out of the way. And so now we integrate. So we have upper limit is t of f. Lower limit is 0.
0.
Or actually, yeah, just wait. Undo. There we go. 0. Of, and we can leave the 7 out. This is a constant, and so we're left with t t e to the 20t dt. And so we can, keeping the chain rule in mind, this 20 would have had to come down and make this 1 down here. So we have it equal to t over 20. Am I good so far? No?
Okay, so this one here, the thing that Nathan's not seeing is you've got the t multiplied by e to the 20t. You can't just use the rule for an exponential. And so this is, well, the last two are a lot harder than the others, I think, generally speaking. This one here requires you to use integration by parts.
So do I need to take the integral of t separately?
What you need to do is to set one function, right, integration by parts. Actually, let me come up and do it rather than try to lead you through, because I'm going to have to tell you every step, and that's kind of hard. So let me show you. How many people are comfortable with integration by parts? It is the reverse of the chain rule. Okay. Let me not worry about what's the reverse of. Here is the rule for integration by parts. Choose a nice color that's different. Integration of u dv is equal to uv minus integral of v du. You can see why I'm saying it's a fair amount more difficult than the other ones. And so what we have to do is identify a function u that I can easily take the derivative of, a function with dv that I'll be able to take the integral of, and that when I do this, I can solve it. Sometimes you actually have to do it more than once. I chose one here where you only have to do it once. And so our definition is going to be let u equal t, so du is equal to dt. And then
let dv equal e to the 20t dt. Notice my dv is a function here, but it's a function that has a d in it. And so now I'm going to integrate this so that I get, and this is the integral that Nathan was going to start to do. If I integrate e to the 20t, and that t should be in this exponent, e to the 20t dt, that's equal to e to the 20t over 20. And so that's what my function v is. So now I'm able to apply the chain rule. Now, keep in mind, I'm doing just this part of the integral, so in the end, I'm going to have to multiply everything by 7. Or not the chain rule, excuse me, integration by parts. So doing my integration by parts, I have the integral from 0 to t final of t e to the 20t dt is equal to u times v, so that's going to be t multiplied by e to the 20t over 20. And then I'm going to have to evaluate my limits minus the integral of v times du. And life is oh so fun. If I apply my limits, upper limit, I'm going to have t final over 20 e to the 20t final minus 0 because it has the t out front. And I'm going to have minus integral of e to the 20t dt. We already did that. It's going to be over 20 squared because I have the 20 from the first one. Now I have the 20 from the second one. Upper limit minus the lower limit, since there was a minus sign, that's why I have a plus now. So that's my integration by parts. And so my final answer, then I just have to take this and multiply everything by 7. So my final answer is and now I check my answer to see if I got the same answers I did before. Yeah, yay! So you can see that was a bit tougher, right? Well, I saved the real toughie for me. Well, I didn't save it. You guys didn't choose it. So what's the real toughie? The integral of t cosine t minus sine t over t squared. This isn't a calculus class, right? As much as it would look like a calculus class so far. And so with something complicated like this, I told you either you'd have to have incredible foresight to solve this thing, or you'd have to work really, really hard, or just use Wolfram Alpha or an integral table. So that's what I did. I put this into Wolfram Alpha. And Wolfram Alpha told me that the integral of t cosine t minus sine t all over t squared gives me, what did Wolfram Alpha tell me? Sine t over t. But I'm not done because I have the limits. That's right. And so I have to put in my limits, which are from 0 to t final. That's a 0. It's not undefined. Why is that not undefined? It's divided by 0, which is why Nathan said it's undefined. It's a 0 over 0. 0 over 0 is indeterminate, not undefined. Indeterminate means it has a value. I just can't tell from this. Undefined means it has no value. So remember, we're applying limits. If we're applying limits, what we really have here is the first one's fine, so I'm only going to work with the second one. We have the limit as t approaches 0 of sine t over t. And so we have to find that limit. And how we find that limit is L'Hopital's rule. L apostrophe, depending on who you read, it's either L apostrophe hospital or take out the S. Either way, it's pronounced L'Hopital. So L'Hopital's rule says that the limit as t approaches, well, I'm going to use x here just so we don't get things confused. X approaches x0 of it says if you have an indeterminate limit, that indeterminate limit can be found by taking the derivative of the top function divided by the derivative of the bottom function. So if we look at my equation here, it's indeterminate because sine of t approaches 0 and t approaches 0. So I'm going to take the derivative of sine t divided by the derivative of t and take the limit of that as t approaches 0. So I know sometimes I use a capital M, sometimes I use a lower M, L. Wow. Sometimes I use a capital L, sometimes I use a lowercase l in limit. So my top function was sine of t. What's derivative of sine of t? With respect to t? Cosine t. And the bottom was t. What's the derivative of t with respect to t? And now if I put in 0 for t, I have cosine of 0 over 1. What's cosine of 0? 1. So I have 1 over 1, or 1. So I came back up here, and this whole thing goes to 1, so my actual answer is sine of t final over t final minus 1. I put this problem in for a specific application of L'Hopital's rule so you can see, yeah, you get a distinctly different value, different answer using L'Hopital's rule than if you just assumed, like people often do, oh, it's 0 because I'm putting in the derivative of 0. Or it's 0 over 0. You know, some people would say, oh, well, 0 times anything is 0. Other people would say anything divided by 0 is undefined. 0 divided by 0, it has a value in this case of 1. Okay, we did go 5 minutes long, but we also did every single problem in the homework assignment. So now you have until next week to upload this assignment. You should all get 100% because you've now seen them all done correctly. Any questions? All right. Auf Wiedersehen. Well, except for Trace.